Okay, today is day 8 with AMI day 9. Things that you are going to need for today's lesson. So, of course, a writing utensil, your 4.2 analyzing graphs of motion with numbers. It looks just like this. So you should go ahead and pull that up. If you are just following along and doing the work off of your phone on another piece of paper, that's fine too, just as long as you're getting it done is perfect. Like I said, if you are on a piece of paper and are not using the printed off copies from the website, you need to write your name at the top right hand corner or left hand corner. I prefer the right. And then PS AMI day 9. Even though this is day 8, we're on day 9. You will need a calculator. There are some simple mathematic multiplications and divisions. You do have to divide by some decimals, but I don't know, maybe you need it, maybe you don't. Your assignment is to read how to graph motion, which is a position time graph with numbers. Be thankful I didn't give you without numbers. Read and complete the example, which we're going to do together, and then complete numbers 1 and 2, A, B, and C for number 1 and A, B, and C on number 2. We're going to do number 1A and number 2A together today. So here is our handy dandy little, let me move myself up here to the very top. We're going to get right into it. I don't want to take up too much of your time. I've noticed that I've done 22 minutes worth of teaching, and this is probably going to take hopefully not too long. So we read at the very top of the paper. It says speed can be calculated from position time graphs and distances can be calculated from speed time graphs. So remember, position versus time is looking at speed, where speed versus time is looking at the distance. And we're going to use the speed equation, V, which we know is speed, equals D over T. That is not the button I meant to push. Okay. So at the very top right-hand corner, look up here at the very top with me, you will notice or you will see that we have the triangle. And if you remember back from October, we used the triangle as a quick little tool guide to figure out how to find the different variables in a 3-point equation. Let me get this stuck. Okay, there we go. All right, so remember to find speed, distance, and time. We put distance at the top because it is in the numerator in the equation. Time at the bottom, and it really doesn't matter which one that you choose it. And then our speed, which is a V, it also goes for velocity. Remember, velocity has to go with vectors, but we still use the V for speed. And so now we can see that speed equals D over T, and that D equals V times T, or speed times time. So in what we're looking at first, follow along with me on the worksheet. It says this graph shows position and time for a sailboat. So we have our little sailboat here that is taken off. And it says that you can see that the sailboat has traveled 10 miles in 2 hours. So he started out at his origin, and he has traveled to 10 miles, which I can see on my y-axis is 10, using my units of miles. And then looking at my x-axis is 2, which is my time for my hours. So I can take what I know about V equals D over T, and I can find his speed, and I can graph it on a speed versus time graph. So I'm just going to plug in V equals D over T. We know that our distance is miles. So he went 10 miles all over 2 hours. So he had a speed of 5 miles per hour. So I can take that information of the speed of 5 miles per hour and I can say how far was his distance in 5 miles per hour. So I'm always going to start at the speed that he acquired through the time. And so he started at 5 miles per hour for 2 hours. So I can find his distance by looking at this, by looking at the area that he covered. And what kind of shape is the area that he covered? If you said a square, you are correct. And how can I find the area of a square? Yes, And so area of a square equals length times width. And I can use this exact same speed equation and say that my distance equals my speed times my time. And so I know that his speed was 5 miles per hour and his time was 2 full hours. These units cross out because this is the numerator, that's the denominator, and it says that he went 10 miles in his total travel. Okay, so now let's look at what happened. If I can get my cursor to move. There it goes. Let's look at a new problem. Let's add a little something to it. The new problem says the sailboat gradually increased its speed between the second and third hours due to the wind. It increased to 7 miles per hour. The speed remained at 7 miles per hour to the end of the voyage. The question I'm asking you to find, oh, that is not what I meant to happen. The question I'm asking you to find is how far did the sailboat go during the 6-hour trip? So let's think back to how we find speed equals d over t. Input our d on top, t on the bottom, and our v. How are we going to find, what is far at? You always have to look in a problem and say, what is it asking for? And so the first thing it asks, it wants to know its distance, how far. Far is just another description of distance. And so I know that I need to find my distance, and my distance equals my speed times my time. Okay, so how far did the sailboat go? So I know, on the next one, let's look. Yeah, so in order to figure that out, I need to calculate the distance traveled between the third and 6 hours. Yes, I just dropped my thing on the floor. Calculate the distance traveled between the third and 6 hours. I'm going to go ahead real quick and put this up here for you for your little cheat sheet. So what's the first thing I'm going to do? I'm first going to ask myself, what do I know? And I know that distance equals the area between the baseline and the plotted line, where area equals length times width. Well, we already know from earlier that we know that this is 10 miles. We need to know what the distance is from here to here, and or from 2 to 3 hours, and we need to know what the distance is from 3 to 6 hours. First one we're going to start out with is the third to 6 hours because it's a straight line and I don't have to worry about, I don't have to worry about triangle. What I mean by straight line is it gives me another rectangle, which you know that rectangle area is length times width. So now I'm going to solve for my 3 to my 6 hour. So if I know that distance is found by looking at speed times time, the same thing as taking the area, I'm going to say that my distance equals my speed, and I know that my speed stays a constant at 7 miles per hour, and that my time was from 3 to 6, or we would say from 6 to 3. So 6 minus 3. And so after subtracting that 6 minus the 3, I'm going to say that it is 7 miles per hour times 3, which equals 21 miles. So now I know that my distance here is 21 miles. But what about my distance there? Okay, so now let's recap. We know that from 0 to 2 hours, my distance was 10 meters. I'm going to separate this. From 3 hours to 6 hours, we know that our distance was 21 miles. Now we need to find what is our distance from here with our triangle. So we're going to say that this is area A, and this is area B. We'll find the distance from there. So what do I know? I know that to find the area of a triangle, it is half the area of the rectangle. And in this instance, we're going to find speed, multiply it by the time, but we're going to divide the time by 2 to find the distance. I also know that to find the area of the rectangle, it's just v times t, or speed times time, to equal distance. And then we're going to add the two areas together. So let's go back to just finding the area of the triangle. So my speed from 5 to 7 was 7 minus 5 multiplied by my time, which my time changed from 3 minus 2. So 7 minus 5 is 2. I'm going to go ahead and put my units. And 3 minus 2 is, oh, and I forgot to do it all over by 2, my bad, is 1 over 2. And this is my hour. And if you put those together, you figure out that that was just 1 mile. Now this area equals 1 mile. So now we're going to look at the area for B. This is find the area of the rectangle. And we're going to say that the area of the rectangle, our speed, was 5 miles per hour. We're looking at this baseline, which was 5 miles per hour. And it went from hours 3 to 2. There was a difference. So 3 minus 2. This is hour. So it's going to equal 5 miles. So this whole area equals 5 miles. Now we're going to take A and B, and we're going to add those together. So we say that 5 miles plus 1 mile equals 6 miles. So in total, in just this one area here, the total was 6 miles. So remember, the question asked us to find the total. Let's go to the next one. There it is. So we said that the area of triangle A was 1 mile. The area of rectangle B was 5 miles. We added those together. A plus B equals C. And we had 5 plus 1. So we're saying that from here to here, let's remember, it's 10 miles. The increase in speed from the 7 miles per hour took them 6 miles. And then when the voyage ended, it was 21 miles. So now we can take this speed versus time graph and we can put it on a position versus time graph. So we know our distance from 0 to 2 was 10 miles. We're going to increase our speed for 2 hours to 10 miles. But then it said it increased it for 7 miles per hour. First distance is 21 miles. Second one was 6 miles, or second distance is 6 miles. I did that backwards. In 2 to 3 hours, 21 miles. So we add those together for a distance of 27 miles from our second hour to our 6th hour. And if you needed to draw your line here at 27, actually 27 plus 10 is 37, and then your point at 10, make a straight line, you can. But this is the position versus time. This is showing the speed. This is showing what kind of correlation did they have? It was a positive. He increased his speed for the full entire 6 hours, and they traveled a total of 27 miles. Okay, so now let's look at your homework. Your homework, number 1, says for each position time graph, calculate and plot speed on the speed time graph to the right. So it gives us the position versus time, and we're going to create a speed versus time. So I know that position versus time is in miles, which remember miles is my distance, hours is my time. So what am I looking for? Am I looking for speed or am I looking for distance? Seeing as we're going to graph speed, I know that I'm going to use speed equals d over t. And I have 1, 2, 3 different types of speeding that this bicycle did through the hilly country. And we can tell that over the distance, we're not finding the distance that they traveled, we're just trying to look for the speed. So in the first one, which is from 0 to 15 miles, I can say that its speed was 15 miles, and then they went up to 15 miles in 1 hour. So we're going to say that it is 15. Let me erase this little blue here so it doesn't start getting all together. We're going to say that in 1 hour, he went a speed of 15 miles per hour. Then I can come over, and I know that at that first hour, the bicycle started at 15, or she, and went in a straight line. Because we're just looking at the distance. So its distance in 1 hour was at 15 miles per hour. But then it shows us that he or she, I guess I shouldn't say that, did not do any acceleration at all, but kept its speed the same for another half hour. So we come over to our speed versus time, and our speed stayed the same for another half hour. It did not increase, it did not decrease. If he came to a stop, then it would show the line going straight down. But he didn't come to a stop. He just continued at the 15 miles per hour. Then after an hour and a half, it shows that he increased his speed. So now that he's increased his speed, I'm going to look, it says that he increased from 30 miles minus the 15 all over the 3 minus 1.5. So I've got 15 over 1.5. Ooh, it's not showing up pretty. For 10 miles per hour. So now I know that he has now increased his speed by 10 miles per hour. So he was at 15. He's now going to increase from 15 to 25. So that's my y. Over what amount of time? He increased it to the third hour. That's my x. I'm going to go find the point that they both meet at and then connect the two lines. Okay? So now the next one says that at 3 hours, it appears that he increased within to 5.5 hours in from 30 to 40. So now I'm going to find his speed, 40 minus 30, all over my time of 5.5, minus, so there's my time here at 5.5, my time here at 3. So the numerator is 10, the denominator is 2.5, which equals 4 miles per hour. And so now he's increased to 4 miles per hour. So I'm going to increase, so it was at 25, he's now going to 29, so I'm just going to put it right below the dot on my y, go over on my x, and it says that it's at 5.5. I'm then going to meet those two together and plot my point, and he increased. So that is our speed versus time graph. And you can see that he's continually increasing his speed until he finishes. And if you want, you can even say that he stopped at 5.5 hours. Or she, I apologize. Okay, so now let's look at number 2. And number 2 just flip-flops and goes from speed versus time to position versus time. So on position versus time, remember, we should see either a positive or a negative correlation. And just looking at this, it says for each speed time graph, calculate and plot the distance on the position time graph to the right. For this practice, assume that movement is always away from the starting position. Remember, this is number 2, part A. It says the honeybee among the flowers has a speed time graph where he travels at 20 miles per hour and then comes to a stop after 10 minutes. Then after 5 minutes, he continues and increases his speed to 5 miles per hour. 5 feet per minute. My bad. I apologize. And then for 5 minutes, he stays at that 5 feet per minute speed. And then he comes to a stop at 20 minutes. And he's at a stop for 10 minutes long. Then after 10 minutes of sitting there on this little flower, whatever he's doing, he then increases again to 10 feet per minute for 5 minutes, comes to a stop. Then he stays at a stop for 5 more minutes, then increases his speed to 10 feet per minute, and he continues that way for 5 more minutes, and then he comes to a stop. He stays on that next flower for 5 more minutes, and then after those 5 minutes, his speed increases to 20 feet per minute for 10 minutes, and then comes to a stop on this final landing place. The question asks us to calculate and plot the distance on the position time graph. So if we're looking for distance, remember, we get our triangle, d over vt. We know that distance equals v times t. So I'm going to use my little area over here to remind myself that d equals v over t. And I've got to look at each of these as their own section. So I have a section here. I can call it A, B, C, D, and E. All right, does everybody see that? And then we'll add these in, all these resting points in between each. Okay, so I'm going to write A over the left side because all we're doing is, remember, these are all just squares. And it said that the area of a square is A equals L, length times width, and we can substitute the distance formula for the same thing. Distance equals speed times time. So my area here, it said that my speed, I'm going to use a different color to show you this one. My speed was at 20. So I'm going to take my speed of 20 feet per minute. I'm going to multiply that by 10 minutes. So I did a distance, this should be feet, of 200 feet. So this one is 200 feet. And then he came to a rest for 5 minutes. Then B says that at B, he went to 5 feet per minute for 5 minutes. I'm going to say 5 times 5 equals 25 feet. So this is 25 feet that he traveled. Then he stopped for 10 more minutes. So I'm going to go ahead and say that this is my 10 minutes, this is my 5 minutes. Then he starts back up again. When he starts, he goes to a speed of 10. So this is C equals 10, and for how long? 5 minutes. So 50 feet. Then he comes to another stop for 5 minutes. Then after being there for 5 minutes, he starts back up. So now we've got distance D that he traveled. And it's the same as the last distance, or not distance, speed, which was 10, for a time of 5 minutes. So he traveled another 50 feet. Then he stayed there for 5 more minutes. At the end of those 5 minutes, he increased his speed one more time, which will be our speed E. Distance E, I'm sorry. And it shows that he increased back up to 20 for 10 minutes. For another 200 feet. Okay, so it said C was 50, D is 50, and his final travel was 200. Okay, so this is the way that we're going to now put the speed, or the position versus distance, and actually look at the distance. Remember, this one looked at speed versus time, this one's looking at distance versus time. Where speed versus time is telling us the distance, where position versus time is telling us his speed. So we should see a linear, a positive linear line on this one. So it says we are starting out, and it reminds you, you always start the starting position at the origin. So we're going to start here at the bottom, and he travels 200 feet. So he goes 200 feet for the first, and we calculated 200 feet for 10 minutes. So at 10 minutes, that is his origin. 200 feet, 10 minutes. Then the next one, it says that he stayed there, and he actually came to a stop. But when we look at speed, we do not kind of like, we wouldn't automatically go down. But what we would do is if he came to a stop, because he stayed there for how long? 5 minutes? He stayed there for 5 minutes. So he didn't change. And then we look at the next one, which is our B, and it says that our B increased 25 feet. That's a different color. 25 feet for 5 minutes. So now we're going to increase 25 feet at 5 minutes. I'm going to go over, plot that point, and then up. We stayed there for 10 minutes. Now I'm going to go over 10 minutes. I promise you that is 25. And then at C, he then increased back up to 50 feet for 5 minutes. So we're going to go over to 50 more feet. So we're at 25. Now we're saying we're going up to from 200 to 25 to 275. Let's make sure. So 200 plus 25. Now we're adding 50. Now we're at 275 feet. And my 275 would be about here. I would go over on this next one 5 more feet. This is at 35. There. And then he sat there for, after this is A, B, C, he sat there for 5 more minutes. We'll go over 5 more minutes. And then it said at D, he increased 50. I'm going to add 50. And now he's at 325. So 325 would be about here. And he stayed there for 5 more minutes. I'm going to plot that point up. And then our last time is E. And so he added 200. And his final distance was 525. So 525 would be about here. And he was there all the way at 60. Plot my point. And that's on. Remember, this is the distance that he traveled. So this is how long that little bee travels among the flowers, going from to pollen to pollen to pollen. All right, so your assignment, you really probably sat there and thought, man, Miss Little has given us so much work to do. But in the end, it's really not that bad. You only have 1B, 1C, and 2B, and 2C to finish on your own. So if you have questions, holler at me. It's the same it's been for the last few weeks. Do not get frustrated with this. Make sure you watch the video. Call me if you need me. Message me if you need me. I am here for you, whatever you need. Until tomorrow. So have a great day.